and subtract mixed numbers today, and what I have up here on the screen is a problem that you might find in a textbook or a worksheet. I would not recommend solving it this way. If you're working with mixed numbers and you're working with whole numbers and fractions, I would recommend that you actually stack it just like you would stack any other addition and subtraction problem. Otherwise, you're going to wind up with kind of a mess on your paper and probably some careless errors. Another thing I would not recommend when you are adding fractions that have different denominators, be careful. I've seen a lot of students, well, first of all, let's look at this one. Are we able to add 3 2/3 to 2 3/4 without making some changes? No, we can't add fractions that have different denominators. We need to change them so that they have common denominators. So I've seen students make all kinds of marks on top of their work. They're changing their denominator, they're changing their numerator. I can't even remember what that used to be. They're changing the denominator again. They're thinking, oh no, what did I do here? It turns out to be a complete sloppy mess. I would not recommend writing right on top of your fraction like that. And so let's see where that problem go. It was 3 2/3 plus 2 3/4. Keep your problem clean. You need to write somewhere, just write beside it. Don't write right on top of it. Let's bring our problem over. 3 plus 2 are the whole numbers. I'm not going to change those at all. It's the fractions I need to change. So I'm going to put the fraction bars waiting for my common denominator. I'm going to look at my denominators that I have and find the first common multiple for 3 and 4. Let's see, 4, 8, 12. There we go. 12 is a multiple of 4 and 3, so I'm going to use 12ths. And I'm going to think, how did I get from 4 to 12? What did I do? Well, I multiplied by 3. I'm going to write that down so that I remember to multiply my numerator by 3. That's another common mistake. People don't always multiply the numerator after they multiply the denominator. So again, I'm going to look at this denominator and think, what did I do? Now don't go multiplying it by 3 because it's not going to be the same. You need to look at this denominator. 3 times what was 12? Well, that one was times 4. So since I multiplied this denominator by 4, I need to multiply the numerator by 4. So now 2 times 4 is 8. Let's see if I can put 8 here. Now I have seemingly a very clean problem, except that I was explaining a lot of extra garbage. So now when I have common denominators, I get to bring my denominator down, keep it the same, and just add my numerators. So I'm going to add 9 plus 8. 9 plus 8 is 17. I'm going to now add my whole numbers. 3 plus 2 is 5. Now when I look at 5 and 17/12, I know that that's actually 5 plus 17/12. 17/12 happens to be an improper fraction. That means the numerator is larger than the denominator, and that really shouldn't happen. So I'm going to reduce it. I'm going to simplify it by taking out a whole number. I'm going to take out 12/12 from 17/12. That's my whole number, right? 12/12 is 1. I'm taking away 1 from that fraction. When I take away 1, I'm going to add it to my whole number over here. So now I have 6 in my whole numbers, and I've subtracted some fractions from 17/12. I've done 17 minus 12 is now 5, and that's 12ths. 17/12 minus 12/12 is 5/12. So I'm going to connect that 5/12 back to my whole number, and my final answer is 6 5/12. Now that was a lot. You might want to review that problem again. The next one's not going to be quite so tricky, but you're welcome to play back this addition one if you need some extra work on that. The next one, we're going to do a subtraction problem that won't have quite as many parts to that as that one did, but again, I'm going to stack it at 6 3/4, and I'm going to subtract 2 5/8. Once again, I have different denominators. I'm going to try to keep it clean. I'm going to find a common denominator for 4 and 8. Well, that one's a little bit simpler, but let me bring my whole numbers over first. So I'm going to bring 6 minus 2, and I'm going to get my fraction bar ready. 4 and 8, the first common multiple that they share would be 8. And 5/8 gets to stay the same, 5/8. It already had 8s as a denominator. And fourths, what did I do to turn 4 into 8? Well, I multiplied it by 2, multiply my numerator times 2, and I've got 6/8. So now I'm going to start again on the right-hand side of the problem, which is what we do on all add and subtract problems. We're used to that. 6 minus 5 on the numerators. I'm subtracting just my numerators. 6 minus 5 is 1. Of course, my denominator gets to stay the same since they're both 8s. And then 6 minus 2 is 4. My fraction here is fully reduced. The greatest common factor between 1 and 8 is 1. I can't reduce it any further. 4 and 1/8 is my final answer. So now we've got a couple of problems for you to try. Go ahead and try these problems. You can pause the screen when you're finished. I'll show you the answers. I also will show you the work that goes along with it. If you have any trouble, please try these by yourself first, totally by yourself, and then check the answers. Check the work if you have something different and see what might have happened if so. Okay, I'm ready to show the answers. Are you finished? Hopefully you paused the screen and completed them. Here we go. And there are the answers. I hope it went well. We'll see you next time. Bye-bye.